Today, we are going to discuss firm behavior in oligopoly markets. By the end of this lesson, you should be able to explain the assumptions that underlie models of oligopoly behavior and set up and solve models of firm decision-making in oligopoly markets. So, what is an oligopoly market? To answer this question, let's consider the spectrum of market structures. At one end of the spectrum, we have perfect competition. In perfectly competitive markets, there are many firms producing a uniform product. Because each firm has a very small market share, firms are price takers. At the other end of the spectrum are monopoly markets. In a monopoly, a single firm supplies the entire market. Because of this, the firm is constrained by the market demand. The firm can either set the price, and the market demand will determine the quantity the firm is able to sell at that price, or it can set the quantity, and the market demand will establish the most that the consumers are willing to pay for that quantity. In between these two extremes are the cases that capture most real-world markets. On one end is monopolistic competition. Monopolistically competitive markets typically consist of many firms who produce differentiated products. Because firms produce differentiated products, they have some amount of pricing power, but they are still constrained by market demand. The last type of market structure is an oligopoly. Oligopoly markets consist of a few firms, each of whom has significant market share. Because there are only a few firms in the market, they interact strategically with each other. If firms are acting strategically, this means that each firm is considering what the other firms in the market are doing when making its price and output decisions. Like all firms that supply a considerable fraction of the market, oligopoly firms are constrained by the market demand. Note that regardless of what type of market structure we are talking about, the firm's profit-maximizing level of output will be where marginal revenue equals marginal cost. What differs across market structures is the nature of each type of firm's marginal revenue function. When considering the types of strategic interactions that can occur among firms in oligopoly markets, there are two dimensions across which the interactions can differ. The first dimension is what the firms are choosing. A firm in an oligopoly market can either choose what quantity of output it is going to produce or the price that it is going to charge for its product. Remember that the firm cannot choose both, because once it chooses one, the other is set by the demand side of the market. The second dimension is when the firms are making their choices. Here, there are two possibilities as well. Firms can either choose simultaneously or sequentially. Thus, there are four models of oligopoly behavior for us to consider. If firms simultaneously choose what quantities to produce, we have the Cournot model of oligopoly behavior. If firms simultaneously choose what price to charge, we have the Bertrand model of oligopoly behavior. Models of sequential firm behavior are called Stackelberg oligopoly models. There are two such models, the Stackelberg quantity leadership model and the Stackelberg price leadership model. We will consider each of these models in turn in the following slides. We will start with models in which firms choose sequentially. These models were first developed by the economist Heinrich von Stackelberg in the early 1900s and are named after him. When might it be appropriate to model a market as a Stackelberg quantity market? First, this model is relevant if firms are choosing how much to produce. Second, this model is relevant in situations when one firm acts as a market leader and the other firm or firms act as followers. This might be the case, for example, if one firm has been in a market for a while and the other firms are relative newcomers. As with most of the models we have studied, we can generate all the interesting results with the relatively simple case of a market with only two firms. So that is what we will do. Firm 1 is the market leader and chooses to produce an output quantity Q1. Firm 2 is the follower and chooses to produce an output quantity Q2. As always, the market price is inversely related to the total quantity of the good produced. We will generically describe the inverse market demand as P as a function of Q equals A minus B times the total quantity produced, which is the sum of the quantities produced by Firm 1 and Firm 2. We will also suppose that the costs of producing a unit of output are the same for both firms, constant, and equal to C. The problem that we have to solve is, how much output will each firm produce in equilibrium? To solve this problem, we will start by considering the problem from Firm 2's perspective. Note that because Firm 2 moves second, it knows how much output Firm 1 has chosen to produce. Therefore, Firm 2 takes Firm 1's output as given. Firm 2's problem is then to produce the amount of output that will maximize its profits given the amount of output that Firm 1 has chosen to produce. To solve this problem, we will start by writing down Firm 2's profit equation, which will be total revenue minus total costs. Total revenues are price times quantity, with the equation for the market price given by the market inverse demand function. Total costs are simply the per unit costs multiplied by output. To maximize profits, take the derivative of Firm 2's profits with respect to its output level, set equal to 0, and solve for Q2. When we do this, we find that Firm 2's optimal output level equals A minus B times Q1 minus C, all divided by 2B. Note that this equation describes Firm 2's profit maximizing level of output as a function of Firm 1's output. Thus, what Firm 2 does will depend on what Firm 1 chooses to do. For this reason, this equation is called Firm 2's reaction function, because Firm 2 is reacting to Firm 1's output choice. Now that we have considered the problem from Firm 2's perspective, we can consider Firm 1's problem. Note that in this situation, both firms are behaving strategically. In part, behaving strategically means considering how the other players will respond to the choices that you make and making your own choices accordingly. Another way to say this is to say that Firm 1 should incorporate Firm 2's reaction function into its own decision. We will start analyzing Firm 1's problem the same way that we did with Firm 2, by writing down its profit equation. The second step is to substitute Firm 2's reaction function for Q2 into this equation and simplify. Once we have done this, we find the profit maximizing level of output for Firm 1 by taking the derivative of the firm's profit function with respect to its output, setting the derivative equal to 0, and solving for Q1. When we do this, we find that Firm 1's profit maximizing level of output is A minus C divided by 2B. We can now substitute Firm 1's output into Firm 2's reaction function to find Firm 2's optimal level of output. When we do this, we find that Firm 2's optimal level of output equals 1/2 A minus C over 2B. Thus, we have discovered that in a Stackelberg equilibrium, the follower firm will produce half as much output as the leader firm will. Hopefully, in a market situation such as this, in which there is an established firm and a new player in the market, it makes intuitive sense to you that the established firm will have a larger market share than the new firm. The final step in solving this problem is to substitute firm 1's and firm 2's outputs into the market inverse demand curve to find the market price. When we do this, we find that the market price will equal A plus 3C over 4. The second type of sequential choice model is the Stackelberg price leadership model. In this model, firms choose the price to charge, and the quantity they produce is set by the market. As in the Stackelberg quantity model, one firm is a market leader and one is a follower. Before working through the details of this model, we should consider the following question. If firm 1 chooses to charge a price P, what incentive does firm 2 have to deviate from this price? The answer is none. If this is not immediately obvious, consider the two alternative cases. One in which firm 2 charges a higher price than firm 1, and one in which firm 2 charges a lower price. If firm 2 charges a higher price than firm 1, then no consumers will purchase firm 2's product, since firm 1's product is cheaper. So firm 2 clearly has no incentive to charge a higher price than firm 1. Similarly, if firm 2 charges a lower price, it will gain market share, but then it will be a monopoly. Thus, if we desire an equilibrium in which both firms are producing positive quantities, it must be the case that in this equilibrium, both firms are charging the same price. Another way to characterize the Stackelberg price equilibrium is that firm 2 is a price taker. Thus, our problem becomes one of solving for the market price in equilibrium as well as the quantities that each firm will produce. We'll change the setup a bit from the previous example. As before, let the market inverse demand be P as a function of quantity equals A minus B times the total quantity produced in the market. Firm 1's total cost function is C times Q1. Firm 2's costs are D times Q2 squared. Since firm 2 is a price taker, its profit maximizing output will be where the market price equals marginal cost, or Q2 equals the price divided by 2D. Now that we've solved firm 2's problem, we can consider the problem from firm 1's perspective. One way to think about this problem is that since firm 1 is the price leader, it essentially has a monopoly over the portion of the market that firm 2 is not supplying. To find the portion of the market over which firm 1 has a monopoly, first, convert the inverse market demand function into a demand function by solving for quantity as a function of price. Then, subtract firm 2's supply from this function to find the portion of the market that will demand firm 1's product. This function is called firm 1's residual demand. Now we can solve for firm 1's profit maximizing level of output and the price it should charge using its residual inverse demand curve. We will start by finding firm 1's profits, which are total revenues minus total costs. We then take the derivative of profits with respect to output, set equal to 0, and solve for the output level. Finally, plug this output level into firm 1's residual inverse demand to find the price that it will charge. The final step to completing the solution is to substitute the price into firm 2's supply function to determine the quantity of output that firm 2 will produce. You should play with actual numbers in these examples to see how the quantities of firm 1's and firm 2's outputs compare to each other in equilibrium. Now that we have considered sequential models of oligopoly behavior, we will turn to models in which firms simultaneously make their choices. There are two types of these models: simultaneous price choice, which is the Bertrand model, and simultaneous quantity choice, which is the Cournot model. We will start with the Bertrand model, since it is the simplest. Before we think through the reasoning of this model, remember that in order for an outcome to be in equilibrium, there must be no forces for change. In particular, there must be no forces that would cause the price to change. Consider two firms simultaneously choosing their prices. Our task in finding the equilibrium is to find the point at which neither firm has an incentive to change what they are doing. Let's first consider prices that are less than marginal cost. At these prices, each firm could increase its profits by producing less and charging more, so no price below marginal cost can be an equilibrium. At prices greater than marginal cost, either firm could gain monopoly control of the market by undercutting its competitor's price by a small amount. Because both firms have an incentive to change their price, prices above marginal cost are not an equilibrium outcome either. By process of elimination, we have discovered that the equilibrium in a Bertrand model is the point where price equals marginal cost. Thus, even though there are only two firms in the market, the outcome is the same as in a perfectly competitive market. This model illustrates an important point. Just because there are very few firms in a market doesn't necessarily mean that they will exercise pricing power. Thus, markets with only a few firms in them don't necessarily generate results that are bad for consumers. It depends on how firms are competing against each other. If they are consistently undercutting each other on price, then the outcome is as good for consumers as a perfectly competitive outcome would be. When considering whether to regulate markets in which firms have market power, it is important to consider how firms are competing. The final model of oligopoly behavior that we will study is the Cournot model. In this model, firms simultaneously choose how much to produce. To analyze this model, we'll use the same setup that we used in the Stackelberg quantity model. The demand for the firm's products can be described by the inverse demand equation, price equals A minus B times the total quantity produced. Each firm has total cost equal to a constant C times output. Each firm's problem is to find the profit maximizing level of output given what the other firm is producing. Note that in this case, since the firms are choosing their outputs simultaneously, neither firm knows what the other firm will do when it is making its decision. We start by writing down the equation for each firm's profits. Each firm will choose its own output so as to maximize these profits. To find the profit maximizing level of output for each firm, take the first partial derivative of each firm's profit equation with respect to its output level, set equal to 0, and solve for the output level. When we do this, we see that the optimal amount of each firm's output level is a function of what the other firm produces. In order for these combined output levels to be in equilibrium, neither firm must have an incentive to change what they are doing, which means that in equilibrium, both firms must be maximizing profits. Therefore, the equilibrium output levels must solve both of these equations simultaneously. When we solve these two equations and two unknowns, we find that each firm will produce the same amount of output and that the output level will equal A minus C divided by 3B. The last step in the process is to substitute both firms' quantities into the inverse demand equation to solve for the market price. In Cournot equilibrium, the market price will equal A plus 2 times C over 3. You should play with substituting numbers into these equations to get a sense of what the equilibrium outcomes look like. Since we use the same market inverse demand curve and cost conditions for the Cournot and Stackelberg quantity models, we can compare their outcomes to assess their relative efficiency or inefficiency. Remember that the perfectly competitive outcome in which price equals marginal cost establishes the ideal case in terms of efficiency. In this case, the market price equals marginal cost, or C, and output equals A minus C over B. In the Stackelberg outcome, the market price is A plus 3C over 4, and the market quantity is 3/4 A minus C over B. Thus, the Stackelberg outcome results in a lower quantity and higher price than the competitive outcome, which means that the outcome is less efficient. The Cournot equilibrium results in a price of A plus 2C over 3, which is larger than the Stackelberg price, and a quantity of 2/3 A minus C over B, which is smaller than the Stackelberg quantity. Thus, of the three outcomes, the Cournot outcome deviates the most from the competitive ideal. If we were to rank these three outcomes in terms of efficiency, the competitive outcome would be the best, the Stackelberg would be the second best, and the Cournot would be the worst. You should also consider where the Bertrand and Stackelberg price outcomes would fall in this hierarchy. Remember that in order to do so, you should consider models in which the demand and cost conditions are the same across all cases. This concludes this lesson on oligopoly markets.